Hello, pre-algebra students. This is Chapter 6.4, Similar and Congruent Figures. To begin, let's review some basic geometry concepts. Let's start with points, lines, and planes. Whenever you see a point in a geometric figure, you're going to see a dot that looks like this that is labeled. We would read that as point A. The notation for a line looks like this and will be drawn like this. Note that this is not a line segment with specific endpoints. The line over the top actually means the measure of, which means that points A and B are on the line but are not the endpoints of the line. Next, let's look at planes. And I don't mean the things that fly in the sky. I mean the flat surface that we're addressing in our geometric problem. The plane here we could label as M. So let me show you an example that includes all of these concepts. There are 3 points in this quadrilateral, J, K, and L. There are 2 lines, KL and JL. And finally, the plane is plane P. Let's go on to segments, rays, and angles. If you're writing the notation for a line segment, it will look like this. The line will have actual endpoints, A and B, and you would write the line segment either like this or like this. Okay? If you're writing a ray, which has a single endpoint, and then passes through another point, you would write it like this, C, D, and then a small arrow on the line above. Finally, you would note an angle by putting this symbol in front of your set of points. So if our angle looks like this, with these points, E, F, and G, the angle would be indicated by angle EFG, and the measure of the angle, which here is 23 degrees, sorry that's a little small, you would write as M angle EFG. This could also be written as angle F, since F is the point or the vertex of our angle, and this could be written as the measure of angle F. Now let's review that vocabulary by looking at this diagram. There is a segment, MP, that is equal to 4 centimeters. There is another line segment, NP, that is equal to 6 centimeters. Notice that we usually put the letters in alphabetical order for our line segments. There are 2 rays, ray PM. In this case, however, we do not put the letters in alphabetical order because the point of the ray is P, or the end point of the ray is P. We have a second ray, which is PN. And finally, we have our angle, angle P, and the measure of angle P is 80 degrees. Okay, let's move on to the next idea. Our last idea is triangles, which we notate like this. Triangle ABC, which would be a triangle with 3 points, A, B, and C. Points A, B, and C are each called a vertex. The plural is vertices. A quadrilateral, which we would actually label simply as quadrilateral. Sorry, that's an R, it doesn't look like it. Quadrilateral, PQRS, which would be a 4-sided shape with vertices P, Q, R, and S. The last concept we want to discuss is congruent segments and congruent angles. Congruent segments have equal lengths, and congruent angles have equal measures. So if we were to draw a triangle with some congruent segments and congruent angles, we'd start with this. Let's label our vertices, X, Y, Z. We would show congruency by using tick marks. So if line segment XY and line segment YZ are congruent, each would have a tick mark through to show that it is the same length. Congruent angles use an arc, like this. The symbol for congruence is an equal sign with a tilde over the top. Okay. Don't get this confused with this sign for approximately equal to, which looks like this. That's not for congruence. This is for congruence. Now that we've reviewed our vocabulary, let's move on to discussing similar and congruent figures. Two figures are similar if they have the same shape, but are not necessarily the same size. For example, let's look at triangle ABC. And let's draw a similar figure, DEF. So these two triangles have the same shape, but they're not the same size. So we would write that as triangle ABC is similar to triangle DEF. Okay. Now let's draw another set of triangles. Let's draw X, Y, Z, and U, V, W. These triangles are not similar. So we would simply say triangle X, Y, Z is not similar to triangle U, V, W. Sorry, we don't have a cute symbol for not similar to. There are some specific properties of similar figures that can help you to identify them. The first is that corresponding angles of similar figures are congruent. So the same angles in the same figures are congruent. So you see here that angle B is identical to angle E, and angle A is congruent with angle D. Also, the ratios of the lengths of the corresponding sides are equal. So we have 5 to 10, 4 to 8, and 3 to 6. As all of the figures or all of the line segments in triangle DEF are twice that of the line segment lengths in ABC, we know that the ratios are all going to be corresponding or similar. So we have a ratio of 3 to 6, a ratio of 4 to 8, and a ratio of 5 to 10, all of which equal 1/2. So these two triangles are similar figures. Let's work through an example where we apply the properties of similar figures. Given triangle LMN is similar to triangle PQR, which would be written like this, triangle LMN is similar to triangle PQR. Name the corresponding angles and the corresponding sides. Okay, so it looks like triangle PQR has simply been rotated 180 degrees from triangle LMN. So let's identify the congruent angles. So our corresponding angles are going to be R and N, Q and M, and P and L. See how the number of arcs corresponds? So the 1 goes with 1, 2 goes with 2, 3 goes with 3. Now let's mark our corresponding sides. Our first set of corresponding sides will be line LM corresponds to PQ. Our next set of corresponding lines will be line MN and line QR. And our final set of corresponding sides will be line LN and line PR. Now let's learn to find the ratio of corresponding side lengths. We have two figures here, ABCD and JKLM, which are similar. Find the ratio of the lengths of corresponding sides of ABCD to JKLM. So we'll write a ratio comparing the lengths of a pair of corresponding sides. Then we'll substitute the lengths of the sides and simplify. So let's begin with side AB, set in a ratio to side JK. Our equivalent ratio will be 8 feet for AB and 12 feet for JK. We simplify and we get 2/3. So the ratio of the lengths of our corresponding sides will be 2/3. We can stop there because the ratios are going to be the same for each side. You can check if you want to be sure. Line DC and line ML are 8 and 12 again, so that will be 2/3. Line AD is 4 feet. Line MJ is 6 feet. That will be 2/3. And the last one here, line BC is 2 feet, and line LK is 3 feet, which is obviously 2/3. So it all checks out. The ratio of the lengths of our corresponding sides is 2/3. Now let's check for similarity using my poorly drawn soccer field. A soccer field is a rectangle that is 70 yards long and 40 yards wide. The penalty area of the soccer field is a rectangle that is 35 yards long and 14 yards wide. Is the penalty area similar to the field? Okay, so here's how we'll work this out. Because all rectangles have 4 right angles, the corresponding angles are congruent. So to decide if the rectangles are similar, we have to determine if the ratios of the lengths of the corresponding sides are equal. So we'll start by writing a ratio for the length of the field to the length of the penalty box, and the width of the field to the width of the penalty area. So let's write our ratios. Length of field is 70. Length of penalty area is 35. Width of field is 40. Width of penalty area is 14. We can find out if these ratios have a proportion or are equal by using cross products. So we'll take 40 times 35 and 70 times 14, which gives us, let's see, 1,400 being equal to 980. Oh, nope, these are not equivalent. So the ratios of the lengths of the corresponding sides are not equal, so the penalty area is not similar to the field. Let's wrap up Chapter 6.4 with our final idea, which is congruent figures. Two figures are congruent if they have the same shape and the same size. In these two figures, JKL and QPR, we have two figures that are congruent because the corresponding angles are congruent and the corresponding sides are congruent. So let's indicate all of that by marking our angles and marking our side lengths. So angle J is the same as angle P. Angle L is identical to angle Q. And angle K is identical to angle R. Next, we know that our side lengths, JL and QP, are the same. We know that our side lengths, JK and PR, are the same. And we know that our side lengths, KL and QR, are the same. So because every part of these figures is identical, they are congruent. Another way to figure out if a figure is congruent, if you are able to manipulate them, is that you should be able to set one figure right on top of the other figure. If I manipulate one figure and set it on top of the other, we see that one can completely cover the other. That means that the two figures are congruent. Now let's find measures of congruent figures. If figure ABCD is congruent to WXYZ, then let's find the measure of line segment WZ, and let's find the measure of angle W. Because the quadrilaterals are congruent, we know that the corresponding angles are congruent and the corresponding sides are congruent. So we simply need to line up our figures and make sure we're comparing the correct side lengths and angles. So line WZ is congruent to line, I think AD, because I think we need to turn this figure by 1/4 turn this direction to line them up exactly. So I think line WZ is going to be equal in length to line AD, which means that our side length is 12 meters. Next, let's look at our angle measures. So the measure of angle W is what we're looking for. And the matching angle will be angle A. So our measure of angle W is 105 degrees. That wraps up our discussion for today. When I see you tomorrow, we'll dig more into this concept of similar and congruent figures. See you then.